Okay, welcome to today's session. This is Jyoti Dodia. Welcome to the Power Virtual User Group session number 77. Today we're going to be covering the POWER9 Enterprise E950 system. Very pleased to have Nigel Griffiths with us. He has been doing some early testing along with his colleague Gareth Coates of this system, so he's going to share his experiences. So without further ado, over to you, Nigel.
Thank you very much, Jyoti. You'll see on this first slide it says the unofficial deep dive. So this presentation hasn't been vetted by anybody in marketing or legal. So these are my personal opinions and not IBM legal statements. Okay, let's move on. I've got a little problem with the windows in here, but we should be okay. Do it okay. Here's a little reminder of what's actually happening in Powerland. The enterprise machines are coming out. We've just announced those. For the E950, which we're talking about today, in 10 days' time, you'll be able to actually have them starting to be delivered to you if you buy them quickly. So it's a very early, quick startup for the E950. The E980 we'll talk about tomorrow. That's taken a little while into September before we can ship those to you. You'll be able to get the PDFs from the virtual user group. And as normal, we're not going to cover every single point, so if I skip through something and you want to read the slides, then download them from Jyoti's website. I'm also going to put the PowerPoint up on my AXpert blog. You can see the URL down there. There's loads and loads of slides. It was very difficult deleting perfectly good slides to try and cut down to an hour and a half that we got today. We're going to spend about an hour looking through the slides, and then the last half an hour or so we'll look at about 100 pictures of the actual servers so you can see what they actually look like in practice when you get one. And it helps explain a little bit some of the technical questions you get. Okay, so first thing we want to make absolutely sure is that when you get your POWER9 machine, you have to have a HMC ready for POWER9, and that means that it's running the 9 series software, or specifically the 920 software, which is an upgrade to the 910. If you don't have that, you will never get your machine powered on, so you can do this in advance. It's supported on the CR7, 8, and 9. And of course, we have the new POWER8 based HMC. We love this. We have been using ours for a couple of years now in testing and now live. It's more CPU, more memory, more disks, and slightly lower cost. So it's a bit of a no-brainer. And the Intel HMCs are going to fall out of stock at some point. Little few little gotchas there that the HMC is now a graphical user interface. It's Enhanced Plus. If you're not familiar with that, you really need to go and practice. There's a series of YouTube videos that are created in another hour and a half will get you up to speed on the new graphical user interface. There's no POWER6 support with the new interface, the new version. So if you've got those sort of computers, maybe you'll want older HMCs to run and control those and buy new HMCs for your POWER9. Okay, and IBM is not supported. I know some people like that. Going forward, we're not going to be supporting it anymore. Okay, let's move on. So let's look a little bit about the POWER9 processor. Now, I've deleted about 15 slides in here. I think I've got about 3 left. We've shown those slides when we released the POWER9 Scale-Out machines. So we're not going to go through the full details. Just a little reminder that POWER9 here has 8 billion transistors in it, and that's almost double what we had in POWER8. And you've got to think, well, what are we doing with all those transistors? So we're going to drop a few little hints in here. There's different forms of the POWER9 chip. The scale-out ones, I think you can see the little cursor on my screen there. Jyoti, can you confirm?
I can see a small arrow.
Small arrow, okay.
Yeah.
So that's going into the open power machines. We have the fused cores that's gone into our scale-out. This is very much like the POWER8 sort of processor. And then we have down the bottom in here, we're having the chips that go into our enterprise machines. The prime difference is that it has the Centaur level 4 caching controller for memory that gives us a bandwidth boost and also does caching for us so that we get a performance boost off that. Okay, this is another little technical reminder that in our, well, I think the techies call it a fused core. We tend to call it full fat, fast fused core. Each of the threads down in here is practically its own CPU. It has the load store, that's reading and writing memory, the integer mass and the floating point mounts and the branch instructions. Every single thread actually has pretty much its own set of these. This means that the threads are much, much stronger in POWER9. There's some implications there about how you decide how big your LPARs are, but we won't cover that today. I think you can see between POWER8 and POWER9 we've sort of added the load store. Then is 4 times, so we now have 8 of those. So each thread can do its own memory. You don't have to wait for the load store unit. It's got its own one to do that immediately. The same with a lot of the maths going on down in here. Some of the less frequently used instructions have just a couple of units. We can share those because the running programs don't use those operations quite so often. So let's look at some of the peripherals. There's a reminder here that this is just a rack, but the T42 rack is slightly problematic with the new E950. The space around the back, we'll cover that later. As a reminder that we're moving over to now the S42 rack, although I haven't actually seen one yet. I'd like to go and actually see one before I fully recommend it. The adapters in POWER9, they've all gone up to Gen 4, the adapter slots in the machine are. You can then put Generation 4 adapters in the machines. This gives you an instant doubling of your I/O rate. So the PCI channels are running twice as fast, and then the amount of data that you can push in and out of the back of the adapter is going to be going that much quicker, latency, and as well as the throughput. Although you don't really need the Gen 4 throughputs, this is 40 plus gigabits per second. The 100 gigabit networks is a good example. That they need the Gen 4 adapter slots. Perhaps some of the other ones, if you're only running a 1 gig adapter network or something, then Gen 3 or Gen 4 doesn't make much difference. They are backward compatible, so in our 950, we have nearly all 4 Gen 4. There's 1 Gen 3 slot in the back of the machine. But that's good for improving the performance of our computers and letting you run at high speed, and maybe running with less adapters as well. That can make you save some money once you've got redundancy.
Okay.
All right, so with the scale-out POWER9 machines, we had these NVMe devices, but there was, like us, a small little bit of card with SSD type technology on it, and you plug that directly in your motherboard. With the enterprise machines, we have NVMe, but they look like this. It does really do look like an SSD, only the plug is very different on the back. It actually plugs directly into a PCIe slot inside the machine, dedicated for this particular disk. As the way we were operating these. So these are called U2 on the scale-out. They're M2 devices, and that's the sort of form factor in here. On the enterprise machines, the drive writes per day is 2.4. So you can write the entire disk contents every single day for 5 years. Is the sort of wear rate. That should cover most people. And if you're worried about it actually wearing out, unlike disks that tend to go pop, the NVMe devices have nice features, and one of those is the fuel gauge. You run a command called the NVMe manager, and I've got an example that's fairly near the end, but we can actually see how much of its lifespan it's still got to go. And then when it runs out, it starts throwing off warning messages saying, it's about time you replace this and do it before it actually fails. Okay. Good. DVDs, like we covered with scale-out, they're gone, they're dead. Get over it. DVDs is now history. All of the operating systems now can be installed from a USB memory key. USB memory keys are a lot faster. You're talking taking down a 20-minute install from a DVD into about 6 or 7 minutes, that sort of number. and they're a lot quicker to burn. If you really, really insist, you can now actually buy a DVD drive from IBM at a fairly stiff price, €222 pounds. That's sort of a new currency that I'm using because euros, dollars, and pounds are all seem to be heading off in the same direction, so it doesn't really matter. Do plug that into the front USB sockets on any Power9 machine because they have slightly more electricity supplied to them, and that helps you run a mechanical device like a DVD if you want to want to pretend you're still in the 1990s. Okay, so let's look at the server range. So here's the Power8 server range that I hope you're very familiar with. We can see in the middle in here the 850, the predecessor of a new machine, and here it is, the 950 for you. 2 or 4 sockets, up to 48 cores, and 16 terabytes of memory. That's 4 times what we had in the Power8. That's the sort of really highlight option for this machine. So let's look at some of the details. Now, I don't want to spend a long time on this slide because I think every single fact we have on here, we actually got a page or two to go through with you. Over here, I think this is an upgrade. I'm not too sure, but the warranty is for 3 years, 24/7, which is good, built in with the price of the box. We mentioned the HMC. We'll talk about the operating systems in great detail, so I'll skip that now. And as JT said, IBMI is not supported. I'm pretty sure it'll run, but it's not supported. We found that it isn't a popular size machine for the IBM community. They tend to like the scale-outs, or they like the whopping great 980s. Now, so we got a range of processors. The processor, this is the Power9 chip that has lots of CPUs on it. And these are the numbers at the top in here of the number of CPU cores you can have. The actual sockets themselves are 8, 10, 11, or 12 CPU cores per socket. The 11 was a late-minute introduction. Only appeared a couple of weeks ago. I guess we have a lot of 11-core Power9 chips available. So rather than calling them Power 10 and blowing one core up, we just decided let's make them available. It'll be slightly down on performance in the 12, but I think there'll be a nice reduction in the price. So swings and roundabouts, you'll have to do that. Have to decide for yourself. Whatever the sort of chip you've got, they're all running at a maximum of 3.8 gigahertz, which is nice. You don't have to do too much maths to decide what you want. 2 or 4 sockets field upgradable. Off the record, there may be a 3-socket version if you really want that later on. Memory, we've already talked about the 16 terabytes and the various sizes. We'll come back to that later. There's no DVD available apart from the external USB DVD, and we're moving over to USB flash keys. On the PCIe, as I mentioned earlier, they're nearly all the Gen 4. There's one running at Gen 3. We added that to run a sort of default network adapter, 2 10 gigs and 2 1 gig, which is a pretty nice adapter as a starting point. That leaves you the other 8 slots, the other 10 slots, 2 at times 16 and 2 at times 8 and 8 at times 16. Those Gen 4 slots are available for your other high-speed adapters rather than your basic network. We'll look at the SAS bays available as well. There's 8 SAS disks in here, as well as 1 to 4 NVMe slots, but we'll cover that in more detail. We've got I/O drawers in here. Everybody calls them MEX, but the feature code is actually EMX, and we have access to storage drawers, disk drawers as well, if you really need to. Okay, so here's a little picture of the machine. We'll actually have a real photograph of the machine later on, but you can see there's 4 fans at the front. Other machines of the same size have 5 fans, and that tells you that these are really big fans. They actually stretch up and down quite a lot of the front surface. So very powerful fans. Pushing through, this is the bay where all the memory is sitting. These are Centaur chips, but then using industry standard DDR4 DIMMs. Then we have the 4 sockets down along in the row in here, and at the back we have all the adapter slots and the service processor. So just looking at the front, these are the slots for the disks. Well, you notice the numbering here, 1, 2, 3, 4, 5. Then it goes down to here, D6, 7, and 8. Pretty obvious when you see it. I may have gone around the corner, but that's the way they've decided to number them. A couple of USB slots on the front. Down in here is the more interesting new stuff. These are the NVMe drives. They're being operated as disks, nothing NVMe over fabric or anything at the moment. I highly recommend using these rather than the SAS disks, unless you really need lots of SAS disks in your computer. This is looking around the back. We have the fairly standard these days for our 4U machines, the 4 power supplies. We'll talk about those. You notice the connectors. Around that are our adapter slots, C12 over here, and C2 over here. So that's 11 slots. That's 10 Gen 4s and 1 Gen 3. On the left-hand side, it tends to look a bit like an adapter slot, but this is the service processor. There's a note at the top in here, the time of day battery actually sits here, and that means you can change the battery very easily. I don't know if anybody remembers, I think it was Power 5. There was a machine that you had to take everything out, including the motherboard, to get to the battery, but we've learned from that. Again, a couple of USB slots at the back. Otherwise, fairly standard. We'll see genuine pictures of this later on. Okay, so we're initially starting off with 2 or 4 processors. We can upgrade them. They are customer install machines and customer upgrade machines for most things. If you're actually going to have to replace the motherboard, we recommend you use a customer engineer to do that for you, because a lot of things could go wrong. And we hope to have the MES upgrades out fairly shortly for the 2 to 4 processors. In the machine, on the left, the right-hand side, we have the 4 processors. Although they sit in a line, they're actually cross-connected like this. It's called an X-bus. Every chip is connected to every other chip directly. So this is a nice sort of configuration. One hop to get to the other CPU on another chip and get to its memory and bring the data back. This is using the X-bus. As we can see, we also have the Gen 4 adapter I/O coming out of the chip. We have the memory I/O, and then we have these very fast buses out in here. On the 980, they're used to connect the drawers together, and in the future, this is where we'd also connect the GPUs and CAPI adapters in here. So we're all ready for that. So here are the actual chips available to us, the 12 to 8 core, and the number depending on how many chips you've actually got in your machine. If you're looking for maximum throughput, then the 12 CPU cores is the way to go. If you want a little bit of a boost, you don't have too many threads, but you just want single programs to run as fast as possible, then actually the 8 core will give you the maximum core strength, because it can grab the extra caches and things for the CPU cores that are not running. These CPU cores in numbers here for the 2 processor version, you can actually get those same sizes for the Scale-Out, the S924, and I haven't checked the prices because they're not available yet, but I guess that would be a cheaper alternative. So you really only want to go for a 2 CPU processors, up to 24 cores. If you want to actually later do an upgrade, its initial workloads are okay, but when we get going, we want more power inside the machine, so we can add the extra CPUs. Or if you want the 8 terabytes that will also be supported with the 2 processor version. The S924 maximum memory is 4 terabytes, and with just the 2 CPU processors in here, then you can get to 8 terabytes. So if those extra 4 terabytes is enough, then that's what you can go for. Okay, so here's some of the RPerf numbers in here. Of course, the RPerf numbers we've got here are for the 4 processor versions, and we can see the RPOS per core go up slightly as you can have less CPUs in here. So highlighting the fact if you're doing batch or low number of threads, then maybe the 8 CPU core chips are the ones you want to go for. The performance report, I've got a URL down the bottom in here to it, classic IBM nonsense URL, but that only came out late last night, so I haven't looked at those in detail. It also has other numbers of CPU cores in the machine, RPERF numbers, and it includes when you're running SMT 1, 2, 4, and 8 in there as well. Okay, so I did a quick calculation comparing it to previous machines, and the best I could find that were offering 48 CPU cores, and you can see that compared to the Power8, we got a 42% jump in RPERS on the top spec machine. That's quite impressive. It's an easy number to remember, isn't it? 42. And you can see if you're coming from an older generation, if you've got a Power 7 first generation, then you're going to go more than twice as fast, 121% extra performance if you jump from there to the Power9 machine. Quite a good way of showing you the extra benefit you get from the newer processors. Of course, the maintenance on our new Power9 machines costs quite a lot less than some of these older machines in here, and you can always buy the machine for free on the maintenance costs. Let's look at memory. We were told that there were two different ways of doing memory for the scale-out and scale-up. Of course, we're talking about the scale-up, the enterprise machines in here. It turns out to be not quite so true. So, okay, so here we have what's called the middle scale-up. This is what we have in the E950. We actually have Centaur chips, but we're actually talking to industry standard DDR4 DIMMs that you buy. Now, I'm a technical person, I have to be really honest. Although we say industry standard DDR4 DIMMs, they are a special server class DIMM, so don't try and grab one out of your PC to put it into an E950. And only if you buy them from IBM will they ever be supported in the machine. So if you call up support and you've got some strange memory, industry standard memory in the machine, we'll ask you to take that memory out of the machine before we start doing support on it. Now, the machine that we're going to cover tomorrow, the 980, that's using the classic, if that's the right word, that we used in Power8, the memory cards, which has the Centaur chip and the DIMMs on an amazing piece of technology, given the size of these small little cards. That's unchanged. Okay, here's a little picture of it. This is for the 950. This is a little card. It's actually on top of the machine. These silver heatsinks in here are the Centaur chips, and they're running the 16 DIMMs we can see on this particular card. You have to input add the DIMMs in sets of 8. And so if this was unpopulated, you see the little white tabs in here? The first 8 DIMMs would go in, all the ones with the little white tabs. And then if you have a second set go in, then they're going to go into the ones with the black tabs, the other set of DIMMs. It's just a good way of reminding yourself where to put them. Here again, some of the memory details that we've had, and we've already actually seen. The bandwidth has gone up in the whole machine. We're now at 920 gigabytes per second across the machine. And I'll just move on at that point. The architecture of the machine, this is always an interesting picture if you can work out what's going on. You can see these are the DIMMs. There's two two riser card with its 16 DIMMs for each Power9 chip in here. I've talked about those high-speed links that we'll use in the future. So down in here we're looking at the I/O. Here are the adapter slots that we've already seen across the back on the 4 power supplies in the middle. We can see this is, although it's called C1, it looks like another PCIe slot. It's actually the service processor. Don't get them mixed up. We've got some NVMe ports at the back. This is how they're numbered, and we'll see there's 2 yellow and 2 green, and they're coming from over here. So the first chip in here has a plex, it's a multiplexer going into PCIe, and from that we're running the two yellow ones, the two left-hand NVMe slots, and this one over here is running the two green right-hand slots where the NVMe slots into the front of the machine. There's a USB controller over here, and we can see a little note in here. There's rather a lot of noise on the line. I hope JT can get to that. Thank you. This is the one that's running Gen 3, so it's the one left, C6, left of the power supply. So this is the slightly slower slot in here. Okay, so that hopefully explains what's going on. You can see that these each chip POWER9 processor has two 16-lane Gen 4s. This one's also got a Gen times 8 in here, and there's two 16s in here, and an 8 and two 16s and two 16s over here, making up our 10 slots. 11 slots, including the Gen 3. Okay, now if you buy the two processor version of the machine, like we have, then you're not going to have these CPU sockets filled up, and that means you're going to lose 4 adapter slots at the back. They're 4 Gen 4 times 16, and we find this fairly restrictive. You've only got the remaining ones in here. This one for Ethernet, although you can change it if you want to, and you've got these 6 over here for all your I/O. We're running 2 VIO servers, and now you're down to just 3 adapter slots for your VIO servers. Just a heads up there. Okay, this is one of those diagrams that we can compare and contrast with the previous machine. You notice here that in POWER8 this machine has dual chips, so for every socket in the machine there are actually 2 chips in that socket. You couldn't see them, but there were 2 6-ways, or up to 2 6-ways. That meant that there was some communication between those 2 actually in the socket that could have slowed it down a little bit. Over here in POWER9 we have single chip modules, so we just have 4 POWER9 chips in those 4 sockets. That cutting down some of the communication between the 2 small chips instead of the one big one is why I think we've gone to 42% extra bandwidth, along with the extra memory in here. But you can compare and contrast these things in here. We have now blind swap cassettes. We'll show you that in a minute. The storage controllers were internal in the POWER8, but now the storage controllers, the SAS adapters for the disks inside, are actually around the back of the machine, and we can pull those out if you really need to. Okay, going to have to move on. This is more of a marketing chart, actually. It's a reminder that with the Power E950, it's packaged up the same way as we did with POWER8. So with the server, included in the server at no cost, is PowerVM. So you've got your hypervisors, your firmware, and VIO servers, and HMC support. There's a little star in here down the bottom that says you do still have to pay for the SWAMA, the software maintenance, but the actual buying of the product is free, and the machine doesn't include a HMC. You have to buy your HMC separately. Same thing with PowerVC. That's no cost, but you pay for SWAMA, which is a tiny size compared to the actual price of the machine. There's Power to Cloud Rewards, which, if I'm right, that allows you to get some education vouchers or service days to help you put the machine in or do some more complicated things via the lab services. You have the Cloud Management Console. This lets you get status reports about your machines on your mobile phone or cell phone or tablet. Look around the machines and see if there's anything going wrong with them. For example, that's an ongoing project. They came out with the Power E950C, and you get that, I think it's for a year or 2 free of charge. The warranty we've already mentioned. At cost options, then we also have the elastic capacity on demand, just like we do with POWER8. That all moves over. The enterprise pool is available for managing your CPU licenses across a group of machines. You notice that's N-1, so the pool can only have POWER8 and POWER9 in it. You can't also have POWER7 in it, for example. You'll have to move the pool away from them if you've got a pool with POWER7 machines in it. You can also get the active memory expansion for AIX, and as an option, you can get the active memory mirroring for your hypervisor memory, increasing the RAS of your machine. With the bigger box, that's the price of standard, that last one. Okay, so now we're going to look at some of the sort of e-config features in here. So these are the feature codes that may help you get the right one when you're trying to configure up a machine. In here we have the gigahertz values. So they're all peak or the standard gigahertz that they'll be running at. Given a few things, we'll look at the next slides, but they should all be running at 3.8 gigahertz in here. If things are getting hot or very busy, they might go down to this level of gigahertz. There's also another one, which these two are running sort of a bit of overclocking of our chip, is the way I like it. The energy scale people don't like me saying that. But this is the bottom frequency. We could run at this gigahertz all day long with a much wider ignoring variability like how hot your computer room is and that sort of thing. But I'm just reporting this because some commands report the nominal gigahertz, but you'll actually be running at this maximum gigahertz up in here. Unfortunately, one of those commands is N1, and I'm trying to get that fixed. If anybody likes N1 and they want to see the maximum gigahertz being reported, which could fluctuate over the day, then write a PMR. That's the way to get those things down. I don't think customers understand how powerful they are if they want things fixed. There's a command, for example, on AIX, the LPOST -E, and then this is the number of snapshots and how many seconds between them. It actually shows you the overclocking percentage. It's pretty obvious when you have a look at it. Okay, now this chart is really an hour's worth in here, so I'm going to skim over the top. I don't know if Jyoti, if you want to schedule an hour about these sorts of things, we would throw in things like the meltdown and Spectre RPerf ratings. We'll look at this overclocking business, and we could look at how to get the best out of your POWER9 processor. But what we're saying is if you're in max mode, which is the default for these machines, then you'll be running between the max frequency and this frequency with no name. Now, I'm sorry, but it's got called no name. The DE and the team involved couldn't come up with a sensible name for it, so they just decided to leave it unnamed, so I just called it no name. So your processor speed will be right up here at the maximum gigahertz. In this case, it's 3.8 gigahertz. It will slide down in here if your machine is getting very hot. And there's a couple of things, you have to do a bunch of things to actually get it hot. That's assuming that your computer room is below 27 degrees centigrade. That's pretty hot for a computer room. My one runs at 18 degrees centigrade. If you go above that temperature, then it will actually slide down to the nominal gigahertz rating, but carry on going. The computers, if you actually go over the maximum temperature that they allow, and we've got that on a slide near the end, then they do actually power themselves off, because they say, well, I know it's going to take an outage of your application, but it's better not to blow up part of the computer at this point, otherwise you'll never get it to reboot. So this is what we're trying to express in this chart. There's also energy power saving sort of things, but we find in practice nobody switches it on. So this is being ignored slightly at the moment. So this is a tweet. I hope you're all on Twitter, and monitoring just a few people like myself. And you'd have already seen this. I did a little series. The POWER9 processors are running between these 2 gigahertz, depending on the machine and the configuration. And you look at Intel chips, and you think 2.4 gigahertz. You're thinking, sheesh, how do they get that to perform? And the answer is they don't. And I look at this as the normal plus overclocking, but I'm not allowed to use that O word anymore. The energy scale guys say, no, we're running at full speed, but we will lower the gigahertz if we get hot. And so how do you get your computer hot for it to be lowering the gigahertz? And I've been here, tried to get the computer hot, and I can't. And that's because my machine doesn't have the maximum number of CPUs in here, doesn't have the maximum size of memory. The 16 terabytes in here does generate quite a lot of heat, you'd be surprised. The maximum disks are pretty hot. You can keep your cup of tea warm all day on a couple of disks. High-speed adapters, they have big heat sinks. That's an indication that it's generating heat, and we need to get that out of the CPUs on the adapters. And of course, you're using all of your CPUs and all of the threads. That's how to get the computer room hot, get your computer hot. And at that point, then it starts pulling the gigahertz down from that maximum. But my machines don't have the maximum CPUs and the maximum memory size, and I can't get them to overheat at all. So you may never see them coming down in the gigahertz because they're getting hot. And then I've already covered that some commands are reporting the nominal value, which could be annoying if you buy 3.9 gigahertz, and then Enmon says you're running at 3.3. You worry that we've sold you the wrong machine or wrong chips or something, but it's not true. It's the same thing. Okay, look at the memory options. These are the sizes of the DIMMs. Of course, these all plug into the up to 8 riser cards inside the machine. I've covered a lot of this stuff already in previous slides, so we'll move on. There's one note in here that the memory that we're actually using is rated at 2,400 megahertz, but we're actually running it slower than that behind the Centaurs. That increases our reliability. Okay, memory rules in here, they're all DDR4. You can't use the memory over from a POWER8 E950, completely different memory. All the memory speeds are the same, the only difference is the size. So each processor you have out of the 4 has 2 riser cards, each with 16 DIMM slots, that's 32 per processor. The minimums in here are not sensible. If you could think of a processor has 2 riser cards, and you had this would be 8, because you have to put 8 in at a time, 8 gigabytes in here. That's using 1/4 of the space in the riser card, so you're never going to get the performance you'd expect from that, because you're only using 3/4 of the port. So I'd say the 256 is like the minimum sensible number if you've got the 4 processors in here. This is the NVMe. We've seen the picture before. Frightening sizes. It showed a solid-state drive at 2.3 terabytes. I haven't looked at the prices yet, but that's quite a lot. I would recommend that most people will be running their 2 VIO servers off these, having a pair in and mirroring between the 2 of them to get your RAS sensible for the machine. That's a sensible config. I can't imagine why a VIO server would need 3.2 terabytes. Of course, you could put these in the machine and just run your operating system on that, and they are fast. I mean, they're slightly faster than the SAS solid-state drives because there's no SAS adapter and changing a protocol back and forth. So they should go faster than that. You could, in fact, run an entire database on these, but then you've got to start worrying about your drive writes per day in here. But it's difficult to decide what to do at that point. Okay. There's 3 ways of connecting up these machines. They're called the 3 backplanes. Remember, the SAS adapters are now in. To run the internal disks are round the back in adapter slots, and so you can run with no SAS disks at the front, and then there's a simple base one, and then there's a split. That allows you to have you've got 4 disks in the machine at the front, so you can split them 4 and 4. That's what you tend to do for 2 VIO servers, for example. Or if you wanted 2 applications, no VIO servers, you could do it that way as well. Well, look, when we get around to the pictures, is these differences in here are largely to do with this one doesn't have any SAS adapters and no cabling to the disk drive, so they never can be used. This one has a cable that goes to the back of the disk drives at the front of the machine, and the cables come down a little tunnel front to back and then plug into the back of the SAS adapters, and so there's different cabling if we want the split configuration or not. So let's have a look. Here we go. This is what's happening. This is if you like, this is back of the fans and the disks above. And so you have an adapter in the back. The two pairs of cables come down to those, plug into these two units here, and then all 8 are connected to this SAS adapter. Forgive me the internal names. This is a GTO adapter. That's the internal name for it. If you've got split, then you have 2 SAS adapters in here to separate them, and then each of those has 1 cable going to the adapters at the back. There's also, in the future, I believe, we can go up to these high-performance SAS adapters with great big caches on them. The caches are shared, so you actually connect the 2 adapters together, and then we have more cables running into the back of the machine, as you can see here. Okay. So, yeah, what can I recommend in here? Well, dual VIO server is what most people are doing. You've got networks, so you need perhaps 4 adapters for your networks, pairing up adapters for each VIO server. For my money, the 2 VIO servers have a pair of NVMe, really fast. There's some possibilities for flash caching as well on the NVMe adapters because they're really quick. There's also, unlike the Scale-Out machines, we can replace these NVMe's with no downtime because they look like external disks really. And in Scale-Out machine, you have to power off the machine to unplug one of these NVMe's. Otherwise, a lot of people are using the fiber channel to run their VIO servers, regarded as pretty normal these days. It seems you have a SAN available, of course. You could use the internal disks. You can put SSDs in those SAS disk slots as well. That will increase the speed quite a lot. Or you could be booting your operating systems or VIO servers from the remote disk drawer. Seems like an expensive way to do that. Now, I prefer to avoid disk drawers if possible, because you have to have SAS adapters to run them. Then you need the actual disk drawer, and that all adds to the price if you just need a couple of disks. Okay, I've already mentioned here the numbering conventions for the actual disks, so we'll move on. Let's look at the operating systems. Right, AIX first. Now, this is a really good chart, actually. Look, we're in these red zone in here. Should have deleted that. There's a HANA version of this machine coming out shortly. I never said that right. But if we look in here, well, they keep calling it mid-range, but it's got an E on the front of it, so it's really enterprise, in my opinion. And these are the versions of AIX that are coming out specifically for it. So if we move on, then this is just general latest version of AIX and some of the features becoming available with them. This applies to any server. For the E950, if your virtualized LPARs are going to use your virtual I/O servers to do all your I/O, and then you have live partition mobility, then these are all available to you. Now notice this is the 7.1, this is the tier level, and this is the service pack level. This is year 16, week 14, and year 17, week 32. And you'll see these have already been out at least a year, so you might be already running these, which means as soon as your 950 arrives, you can do live partition mobility straight onto your new machine, get the performance jump and all that. If you're using AIX with adapters at the GA date, then these are the 2 versions you'll need, because, or particularly if you're using NVMe, because the older versions don't understand what to do with them, but these are the supported versions as well. And then later in the year, there's some updates to these coming out and some noting in here. And of course, nobody should be running AIX 6.1 anymore. Or if you are, you should be asking for the server extension, or you're not supported. Okay, Linux. This is going to be a bit contentious in here. Okay, so Linux on Power, and I've got the wrong. I copied it over. That should say 950. We'll fix that up in here. So if you've got older versions of Linux, they've been running in POWER8 mode on POWER8 machines, so one hopes. And so they're going to be supported. You can move those to POWER9 and run the POWER9 chips in POWER8 mode, and they'll be fine. The various vendors are releasing new releases, and some of them support more of the POWER9 features, you should be asking your Linux vendor about those. But if you want the best chance of having POWER9 optimization, I know SLES 15s has some of that, and the RHEL 7.5 definitely has POWER9 support, so it's using some of the POWER9 features. Okay, so somebody needs to mute their microphone. Thank you. You note, if you're running in POWER8 mode, you'll get most of the benefit of POWER9. All right, so the chips are just faster. All right, there's no way we can stop you doing that. If you're trying to use some of the POWER9 features, then you'll need these particular versions. And we've had a bit of a problem recently, is that it's called RHEL 7.54 POWER9. But when you go to the Red Hat website, people can't find that, and they've now called it the alternative version, the alt version. So this is a hint in here. You're looking for a download that has alt in here rather than POWER9. Yeah, you heard that IBM is known as it's been moved. Well, this case it's Red Hat is being moved on their website. Okay, now Ubuntu. This is the connectors bit. Ubuntu on PowerVM is no longer being supported by IBM. I don't think you can run Ubuntu or any of the Linuxes actually on the raw metal on a 950. We expect you to be running in PowerVM mode. I guess you could run a single LPAR with no virtual IO servers, but Ubuntu is not being supported on PowerVM. So that's these two versions that we can have out in here. This includes POWER8 and POWER9 machines. Now, it does actually work. It's just not longer supported by IBM. You could talk to Ubuntu. They may support you. But classically, in the past, you could phone up Canonical for support. They'll support you level 1 and 2. But if they really think it's a POWER9 problem, for example, then at level 3, they'll pass it to IBM. And IBM, at the moment, will now say, sorry, we're not supporting that configuration. Now, if you previously purchased support for Ubuntu 16.4 in POWER8 mode, then we'll continue and we'll honour the supports for that for 2 more years. So we're not going to force you to do something immediately. Now, native Ubuntu on the base metal, by which we mean non-PowerVM, is still fully supported by IBM, and that's what you tend to use on your AC92s and your LC92, 91. I call these the super micro versions of your open power machine, and this is the GPU machine with fancy graphics adapters in the back. Okay, so I think maybe a shock to some people that haven't seen this before. RVMI is not supported, so that's a nice clear message. The VIOS server is the latest version, 226.23. I think we've got 22 internally at the moment, so that will come out before the 17th of August, ready for the machines. Don't use older versions of the VIOS server, because your VIOS server doesn't have live partition ability for your actual VIOS server, so you should always have the latest version of your VIOS servers. So start with a new pack with the latest version, particularly if you want NVMe support. That has to be on this version up in here, not some older version. But I'd recommend this higher version. VIOS server 3.0 is coming very soon. This is based on AX 7.2, but we're going to have that later in the year. Right, storage and remote I/O drawers. This is very much like POWER8 because it's the same storage drawers and the same adapter remote drawers as well. So this shouldn't be a shock to anybody. If you have your storage or I/O drawers attached to POWER8, you could unplug them from your POWER8 machine and plug them into a POWER9 machine and move all those adapters and your disks over with them if you want to do that. And okay, so the remote I/O, the disk drawers are the same part numbers and everything in here. You'll have to have the right adapter for the E950. It's a full height adapter. These are the high full height and the low profile version of the same adapter. A little bit of care migrating. Make sure the adapters and if you're bringing the adapters over as well are up to date. the actual drawers and the adapters are up to date. But examples of the larger discs and the new 2.5-inch discs are the prime difference. If you've got a remote I/O drawer, people call it a MEX drawer, but it's an EMX feature code, and the same sort of message in there. This is just a little reminder because I tend to forget these things. The drawer is a MEX drawer. Each half of it is called a fan-out unit, and you can have just one half drawer with one fan-out unit in here. You'll go in your server, you'll be down one adapter slot as you connect into these connectors in here to the half drawer, but then you gain 6 adapters in here. So you're down 1, up 6, so each half drawer gives you 5 extra adapters. And if you do the maths, you can get to 51 adapters. That's fairly mad, in my humble opinion. That's a fairly expensive way of running a computer with all that. Right, coming up in here is a bit of an eye chart. Okay, thank you, Jody. Okay, so these are drafts. I had to go and check, as we only announced yesterday, that all these feature codes actually arrived. I'll do this before we put the slides up onto the download sites. But you can see we've got lots of SAS adapters in here. You'll notice that the 950 has the full height adapters, and the remote I/O drawers have the same size, which is nice because you can actually move them back and forth. We've got various SAS adapters, including these ones you need for running the disks internally. We've covered the adapter slot already. In here we've got disks. You'll notice that some of them are lots because they could go into the remote I/O drawers, and you can have lots and lots of remote I/O drawers if you really want. But some of them are only 8, and that's because these ones in here go inside the machine, and they're small form factor 3. They're a little bit thinner than what goes into the remote I/O drawer. So this is why, I don't know if you've ever been in eConfig and you've added one disk and you thought it was going to go internally. If you pick up an SSF2, it will say, oh, that can't go internally, and then it will throw an adapter and a remote drawer and add the adapter, and the disk, in this case, into the back. So that's a very quick way of working out these ones are inside the box and all these ones are in the remote I/O drawers, just by the way, and hopefully stop people having to remove I/O drawers. Lots of disks in here and more disks in here, all the different sizes and SSDs and that sort of thing in here. No problem going down. Okay, networking again. You'll see the 10 in here is when it's internally, and 50 to 51. I don't know why there's 50 and 51 on this chart. A little warning in here. We discovered, this is Gareth kicked in and asked questions about this. Fiber channel over Ethernet. Although that appears in the name of these adapters, we're not supporting that going forward. If you're into fiber channel over Ethernet, don't worry, you can ask your IBM representative for an RPQ, and then you're allowed to, they will support you for that. But we effectively want to know who is using fiber channel over Ethernet and offer support. As we all thought that it was going to get very popular, but it turns out that not many people are doing that. We're keeping our fiber channels and our networks separate. Then again, here's the CPU and memory in here. Although it says in here you put 128 of these in here, in total there can only be 128 in here. And here's the NVMe at the bottom. Right, now so that's an eye chart. Couple of little things in here. I think I just slipped. Nope, I thought there was another slide in there. The power supplies in here, we're 2 plus 2. So you start the machine with 4 adapters, 4 power supplies rather. If one of them fails, we just carry on running, that's fine. We can actually suffer another hit while you're running with 3, so we can go down to 2. It may tune down your gigahertz rating to try and reduce the electricity inside the machine, but it should allow you to put in your replacement adapters. Of course, don't wait for the 2 to go down to do that. We'll come back to that when we're looking at some of the pictures. Okay, then here's the physicals. That's what the slide I was looking for. This is the size of the machine in here, yeah, it's big. It's 5 inches bigger than the previous generation. It's a bit of a shock. It sticks out the back of the rack, past the rails where you mount the rails. And we'll look at again into that when we see some pictures of that. It's also heavier. I'm told this is because primarily because of the extra memory inside the machine. There's a lot of parts in that increasing the weight, and you may want to consider it's a four-person list, but if it's above shoulder height, I strongly recommend getting a lifting tool to lift it into the machine. Electrical power in here, I don't think that's changed very much. Here's the machine type model, and I like this because it says, it's a 1940 Mr. 9. Maybe that's me. Okay. And another warning in here is using different connectors. Normal, what we call kettles, or C13s, we're using C19s and C20s on this machine. That was a little bit of a shock when we put it in, and we had to go and find a PDU that would match. If you're replacing 850s with 950s, you can't plug them in when you get there. Okay, got the just the facts that might be helpful. You can't run the machine over 10,000 feet, which is a pretty big mountain, and it is fairly noisy. That is because of the fans used to pump the air through the memory DIMMs. It's noticeably noisier than the 850. Some countries and some companies have laws or rules governing the amount of noise that people can work in. So you may have to consider your noise policy and get ear coverings to run in the computer. It's particularly noisy when you power it up. It quietens down a bit after that. So this is my sort of call to actions in here. It's like the previous model, but some a whole bunch of improvements. Of course, we get the performance boost, which everybody wants. We've got the memory jump. I know some people like the SAP cards are like, wow, 16 terabytes, we can use that. And so that's going to be very popular with some of those in-memory databases workloads too. We have PCIe cassette access to the adapters. I'll show you that in a second with pictures rather than anything else. Get your HMC available earlier on. And just those warnings there, electrical connections, the size is a bit longer, it's heavy, and it's noisy. Right. Oh, here's a... This is one of the marketing slides with lots of things on it, and I had to upgrade the font size by about 5 to actually make them readable. We're now going to have to flip to another presentation. It's got all my pictures in it. Okay, so we'll stop sharing for a minute.
While Nigel's doing that, just a reminder that we are going to be taking questions right at the end today. Tomorrow's session will be covering the E980s. So same time, hope you can join us then as well. Nigel's just going to switch to another presentation deck.
Well, that's the theory. All right, there we go, it's starting up. We've lowered the resolution of these slides so that they work a little bit better on the internet. Great. What's happened there? Oh, there we go. All right. And share an application. PowerPoint. There we go. You can see my PowerPoint directly there, I hope.
I can, yes.
Okay, we'll go full screen. And there we go.
Yep.
Good.
Yes.
Good. Okay. So we've had a machine for 3 months now. And part of the early ship program, and it's fascinating looking at the brand new kit. We like doing this as a job. We note that the E950 is a custom install, but it is built to enterprise standards. I mean, the key thing that's different is we have a single service processor, and I don't know how many service processors fail out there in the wild. I don't think it's that many. That's the one key difference between it and the bigger machine in sort of RAS and enterprise standards. Hopefully this will give you a little bit of information about what it's like when you actually get yours. Here it is. For some reason, our mailroom decided it looks better on its end. It arrived in a computer room like this. But now this was actually shipped from a development lab that has a sort of pre-life before we saw it. But all the boxing up and things is much the same as we expect in real life. They shipped us some cables for a remote I/O drawer in here, and the big box across the top is the rails. And And so we lift those out. Here's the actual machine, very standard wrapping. So this is all available 3 months ago, so they're well ahead of schedule. Oops, let's go back. It's a plastic bag out of the way. You can see great big labels on the top explaining where everything goes and the numbering conventions of the adapter slots and those sorts of things. The yellow ones are the warnings about the weight, lifting it up. Here we are. We've drilled into those. We've had some fun with these. You really want to. I don't think you should use a forklift truck. It's a little bit indelicate. There's a thing called a lifting tool that you can wind the handle and raise the height of the adapter, the machines. Or you can go for weight reduction, where it says take the front off, take the fans out. They weigh quite a lot, to be honest. Here's the power supplies, and we don't agree with this one. I'm not sure if they're going to fix the sticker for GA. This looks like 12. Take out the 12 adapters, but the left-hand one is the service processor, and we found that quite tricky to put it back in. It's not a standard PCI slot. It's a much more complicated slot than that. So I'd recommend you leave the service processor in here. And here's a classic diagram. It's two people and a co-joined twin in here. I don't think they are really. And if you then actually take the memory out, lift the lid and take the memory out in here, they reckon that you can get down to 3-man lift, but it is heavy, and strongly recommend use a lifting tool. I've seen pictures of the development labs, them using the lifting tool. We go up to 42U in a rack, which is well over my head. We have some customers that have racks that go up to 58U. I mean, it's like in the ceiling. And then you really need a lift tool. And in fact, with those sorts of racks, you have to lift the machine out of the rack to do any maintenance on it at all, because you can't actually see the details. But anyway, moving on. Here's a little blow-up of the picture on top, helping you find out where things are and what they're called. And I note in here, these are actually called fans. They used to be called air moving devices, but there we are. Makes more sense. And the numbering conventions for the fan numbers and the adapters. It has these lovely round fans. Remember, this is customer installed, so we don't want to, cut into your hands with little thin strips for the handles. These are really beautifully made handles. With the 980, that's going to be a CE, so he has cheap and cheerful handles to lift and put it into the rack. But the 980 is likely to be at the bottom of the rack. You may have racks full of these machines. Moving on, here it is on the bench. We can see the big fans on the front. In here, you can see the 8 discs. We just pull one out slightly in here. Standard, press the blue button, the little handle pops out, lever the handle out, and it pulls out slightly for you. We've got the LCD over here and the buttons over here, and we'll have a look at those in the next couple of slides. So here we are. Now these fans, when they're going full speed, when you just power it up, and they're going so fast, they literally grab your hand and suck your fingers onto the grill. I'm very happy that there's a grill on the front of these things. They're very powerful and very noisy fans. So there's everything that I mentioned before. Here's the serial number. We have a handmade machine type model and serial number sticker on here. You pull the little blue tab, and then you have a little handle, and you use that to pull it out of the rack. Otherwise, you haven't got anything to grip onto. These are the NVMe slots down in the bottom here, and we have a nice IBM logo, which is still covered with the sticker. So this is looking down the middle section in here. So we have we only have 2 POWER9 processors. They haven't got the full range of cores. Remember, this is an early ship machine. It has 2 dummy baffles in here. We've got a better picture of that, I think. So these are all the memory. We've only got 2 riser cards, so the blue handles on here, and there's 2 fillers in here. We can't plug these in because we don't have CPUs over here to actually run them. This is the vital product data, the lollipop that says how many CPUs and memory that you're entitled to and things. Somebody's asking about the LCD panel. Is it optional? No, it's not optional. As far as I know, I haven't been to eConfig to go and find out. Okay, so each one of these has 16 DIMMs on it, and we saw a picture of that earlier, didn't we? Moving on. Right, here's the dummy CPUs. I think these look a little bit like a TIE fighter from Star Wars, but maybe that's me. Just a little picture to have a look. Here's the actual CPUs. Nice tall lots and lots of fins, block of copper down the bottom to get the heat off the processors. But we've seen these sorts of things before. There's another look across it, and we can see the numbering of the riser cards as well. You unclick these handles, pull them up, and then this little bit in here pushes on the metal, and it'll pull it out of the connector, and then you lift them out. These are just popped in. Cheap and cheerful. Okay. Down. Having trouble getting to the next one. Okay, we've seen this slide already. Here's the two handles that release it, and here's one that's fully populated. The blanking plates here pretend to have the things in there to keep the airflow going for the ones that are populated. I thought it would be nice if they spell IBM with those things, but it looks like a 9-bar gate logo. Here's the back of the machine, 4 power supplies, adapters left and right. This is the service processor in here. This is a little cover for the battery. It's sort of sticking out, so you can change that quickly. USB at the back in here. Don't forget the DVD, plug it in the front. There's a more electrical power to it. These are the SAS cables. So here's the tunnel that goes down to the behind the discs at the front of the machine. You can see we've got 2 cables out in here. We didn't know anything about this when it arrived. So if we unpack these, take the foam, the bubble wrap off the top, then there's 2 sockets that will plug into. I think it's these 2. This is one of the SAS adapters in here. We'll plug into these 2 sockets in here, and then it would activate the discs around the front. We decided not to use the SAS adapters because we only have 6 working, because we don't have enough CPU processors, and we wanted to use other things in those slots. Okay, so here's looking a higher level view. These cables run down this track to the back here where the discs are. Here's a view with the cable bracket on in here, a little bit like the. I'm not sure if the 850 has this. I don't think it does. It has a cable management arm, doesn't it? So it's a bit like the 880 and the 980. So it's a little bracket on here. You pull the blue buttons and put it up to the higher position, and this moves everything up. Gives you a bit more space to get the adapters out of the back of the machine. And you're meant to put the cables underneath it. Otherwise, the machine above, if you try to pull an adapter out of that one, then it would hit the cables on the top of this bracket in here. In this case, you can see we get the power cables going out in a fairly tight curve to get them out the way. That's because you can't quite see. You can see in here, this is the rail that you mount things on, and it's 5 inches away from the back of the machine. We'll see that in other diagrams. Here's the voltage regulator modules. This smooths out the voltage and current going to each of the components, and will save them. They'll commit suicide if necessary if a great big spike enters the machine in the electrical power, and it makes it easier to run at high speeds inside the computer. Here's looking at one side. Sorry, I thought I took this slide out, but anyway. So this is the service processor in here with the 2 HMC sockets on the back, as you might expect. We're looking at the adapter remote slots now. Well, that's the service processor in here, but you press this little button on, press this lever in here, and it unconnects it from the back of the adapter, and then you lower it down, and here you can see that it goes, when it's in the up position, it's locked up like this, holding the adapter in. When it's down, it's turned over, then you can gently pull the adapter out of the back of the machine. Here's a reminder of things to do. So you release the catch and turn it down. That should pull out the adapter centimeter or so. I didn't realize, I thought this was something to grab, but it actually has an axle here, so you can turn these over, and that releases the top of the adapter, the tailstock here. Then we've got some slide runners in here. I've got more pictures in a minute. Then we've got a release in here that took me about an hour to work out how to do it. So you'll know on day 1. Right. Okay, so here's our adapter. You push these down and release them and slide them back out of the way, so you've got some room to take the adapter out. Here's the little thing that you turn over to the up position, and then you're thinking, right, so that's good. We're ready to pull the adapter out. Then you want to pull the adapter backwards because it's tailstock in here, so you can't move it upwards. But the PCI socket in here stops it going backwards, so it's a bit flummoxed there. And this is what you need to know. So you hold this bit firmly. This blue track in here is not just for decoration. You press that down, and this edge in here goes below the aluminium in here, and then you can slide the whole blue piece backwards with the adapter in it. Once you've done that, then you can see the tailstock has been freed. Then you can lift the adapter to remove it and take it out of the blind swap cassette. And that's taken me about 10 times longer than it actually takes to do it. Here's a little picture of the other side of the cassette, and you can see this thing in here allows it to move from here to here, and this is the connector in here that does the release mechanism. And once you've done that, then the actual real connector into the machine is about 2 centimeters further back in that position. Now there's not much on here, in fact nothing. This is just a little piece of motherboard connecting the two pieces of the PCI slots and the thing that goes into the back of the computer. This is the service processor with the this is the battery in here with the cover removed. This is actually a PPC PowerPC processor running a machine, of course. It's sort of related to the PowerPC machine still running the Mars rovers up there on the remote planet. Right, something completely different. And here's the fans, very impressive fans. You press the button here, the little handle pops out. You grab the handle and move it around the front, and then it's already pulled the fan out a centimeter, and then you can lift it out. And you can see there's in the back in here, there's fold-down connectors, fold-down flaps. So if you pull this one out the air immediately, it doesn't go in this fan and out this gap. It sort of closes that gap off. These weigh quite a lot, very powerful fans, pushing a lot of heat through. It's mostly, I was told by the developers, for the memory. The 16 terabytes of memory does take some cooling down. We've already mentioned this, very noisy, louder than the 880 next to it, until it steadies down and it slows the fans down. Okay. Down below in here we have, this is the disk in here, blue button, open this and pull the disk out. This is the NVMe, which is sort of a half-height disk, is what it looks like effectively on the front of the machine. Here's the the SSD part of the NVMe. The connector at the back is very different. It won't go into a regular disk slot. A quick look, yeah, we have a handmade serial number in here. This is an odd bracket. We were very puzzled by this. Weren't quite sure. We've got two of them. What to do with that? And then we eventually worked it out. It's just to hold this cable bracket at the back of the machine. The machine, here's the way you normally connect the rails. So the rails actually come out the back of the machine, comes right out to here. And this is specially designed so that this is slightly floppy, so that the machine comes through this area. I think I got this on the next slide. Yeah, so this is actually putting it on the back of the rail where you normally put the rails on. And you tighten these up. You tighten these up completely, but it still sort of moves around a bit, and that's because we want it to line up with the machine as you push it in to get it nice and at the right place when the machine is actually in the machine. There's two sorts of rail in here. If you're in the 242, you need the thin rail. If you've got plenty of space, you've got the wider rail in here with more places to tie your cables up to. I think the S42 rack can cope with will have the wider rail. We have this improvised thing in here where we have a similar thing with other machines, but with the 950, you have two brackets either side, and then this rail just slots into the hole. Here's the hinge, if you like, in here. And as you're trying to put the thing in, it keeps falling apart. So Mike Pearson, Computer Room Manager, put some Velcro around it to hold it all together as we screw in both parts of it. Okay. Now, to get the machine running, of course, you need the HMC. You're running a 9 series software. This is actually 22623 in here, and a new copy of AX. We're now running all this Slayers 15 and Ubuntu, although that's not supported. But I'll point that out again. So here's the 11 quick observations that we thought we should know about. Completely caught out because we didn't read the manual and we didn't have somebody presenting a webinar to us. That the regular kettle lead C13s don't work in here. These are high wattage cables, so we had to go and sort that out. There's a picture of them so you know what to expect. The other ones have the pins running sort of up and down rather than side to side rather than up and down in here, and I've got a picture of the PDU that you need to match those up with, supplying higher voltages. Important, this one. When you plug in your 4 power supplies, 2 of them should go to one PDU and 2 of them should go to the other one. The top 2 and the bottom 2 have to go to the same PDU if you want your reliability. We've had a number of customers with 850s, E950s, who haven't done that, and then one power supply outage actually took the machine down. Now you know. Something we did wrong, we should have realised this one, but don't go there. Sort of message in here. When you're lowering the machine onto the rail, you put the inboard nail head in first, into the area on the rail, the space on the rail, and then you lower the front of the machine down. We lowered them all at the same time, and this one didn't go in properly, and it sort of bent the rail slightly, and then it wouldn't slide into the rack properly. So we had to lift it back out and get this done properly and get it fixed up. Don't follow our advice. I think this is a 4-person lift. I do worry about countries where people are tend to be shorter, shall I say. We had 4 rugby players lifting it in. That's quite easy, above waist height. I recommend the famous lifting tool. Next to us, it's surprisingly long, so I looked up the details and I was, great guys, that's really helpful. So we converted it, so it's 5 inches longer, and it sticks 5 inches past the round rails supports for the rails inside the machine, and it's hard to stay inside a T42. With our cables, they actually push up into the foam of the door, which I don't like. I don't want every time I open and close the door that we're moving, bending slightly some power cables. If you've got the remote I/O drawer, the connectors for the remote I/O drawer are quite big, and I don't think you can actually shut a T42 rack. So we strongly recommend an 8-inch extension to your rack, or the S924 rack, which has, I think it's 2.5 centimeters more space at the back for your cables. And if you've got third-party racks, again, be very careful with that. So if you're upgrading from 850s to the 950s, be wary of that. You may not be able to close the door. You can see in here, this we put it in initially with the wider bracket in here, and this hit the door, and we initially went over the top in here. This is all terribly wrong, and we fixed that. You saw a picture of that. Oh, here's a picture of it again. With the cables. What I really like is some of these C19 cables that actually have, a 90-degree bend on it. That would get rid of our problem, but you still have problems with those remote I/O drawer cables who will be sticking out the back. You certainly don't want to break those closing the door. With ours, this pushes up against the foam. These ones here. That's okay. We only got one of these machines in the rack. If we had the 4U, you could have 10 machines in the rack. That would be quite a struggle to gently bend those back in as we close the door. Oh, another one we found, inside the lid, top lid, there's a couple of diagrams that are useful about inserting your memory and things, in which orders. If you just take the lid off the machine and place it on a table, you won't notice these labels. We recommend that they put a see other side for more details. Number 6, we've got HMC had a horrible picture when we started off. Remember, we were early days with beta code. They eventually made it look like a black POWER9 machine, and we've told that the developers are fixing it. I mean, I would like to have, take a photograph of my machine and have them on here, but maybe that's not too much. But at least I like it to see it look like the machine. And this is a 2U and this is a 4U. I'd like different sizes in here, but maybe I'm getting too fussy. If we don't get the right pictures, raise a PMR. They'll have to go off and fix it. Okay. Missing slot numbers in here. Yeah, we can see we have 2 to 12, but we have 4 slots over here which aren't in use because we don't have the processors. And it confuses a bit because the numbers on the NVMe were mixed in. Okay, so here's 2 to 5 are missing in our list on the HMC because they're not available because we don't have the processor. But then we do have these non-volatile memory controllers in here. If we go to the next slide, it's zoomed in. So we thought this was 1 to 4, and what happened to 5? Sort of thing. And then we realized, hang on, this is a slightly different naming convention. If you look over here, here's our 4 NVMEs, and so these are separate PCIe ports or something that can be assigned to different LPARs, in our case here, 2 VIO servers. So they're completely independent, which is nice. You don't have this having to have split cabling or anything like that to get to them. Here's a reminder, we don't have these 2 CPUs, so these 4 slots disappear. C1 is actually the service processor. Okay. I talked about NVMe in the last 3 minutes and worrying about how much I/O am I doing on a daily basis. Well, you can find out now. Here's the command. If you use lsdev and look for NVMe, it tells you about your adapters, or how many you've got in here. This is on the VIO server. It's only got 1 of the NVMe assigned to it. It should be 2, but we didn't have the spares. And it's saying here in red, percentage of life used, 0. So in 3 months, we haven't even got to 1% yet. And we can see down in here the size is just under the 800 megabytes. Of course, they're using 800 million bytes standard disk technology. And there's some other things in here. You can see the temperature in Kelvin. That's pretty strange, isn't it? And available spare space, the extra bit that it keeps secret is not even being used yet for any failed partitions on the disks. Okay, so nice command, and you can go around once a month, check how much you've used. If you want to check the performance mode, you go into the HMC, as in here, get to the ASME panel, and then you go System Config, Power Management, Power and Performance Mode Settings, and you get a panel that looks like this, and the default should be Maximum Performance Mode. That's how you get up to the maximum gigahertz. Surprisingly noisy, please read the documentation and take suitable protection of your ears. This is just a very bit of fun, really. Nmon approved. Nmon works quite happily on here, although we're giving you the nominal gigahertz and not the real. Why not raise a PMR when you get your machine? And we'll see if we get that fixed. Number 11, out of 11. There's no need to lift the lid unless you're taking out, upgrading your CPU or RAM. You could do it for weight reduction. So one reason of doing it. And if you're if you're going to fix or replace your CPU's MEM or your voltage regulator modules, it means that most of the computers will never have the lid lifted. So you'll never see this little sort of issue in here. We found it difficult to reset it. So this is precisely 30 degrees. Bring your protractor in to get that right. And then you put it into the little groove in here, and you push it in slightly. There's a rubber filling the gap in here. You want to push that slightly, and then you lift the little handles and pop it down. If you don't get that working properly or push that in slightly, then there's underneath these things there's a thing that will hit the edge of the casing in here. There's a clunk, and it'll be 2 centimeters short of getting it back in. So have another little go fitting it. It worked fine once we knew that. In the PowerPoint that I'm going to share on the AirExpert blog probably later today, maybe tomorrow. Loads of very high quality pictures, but we didn't include these in here because it would make the presentation like 35 megabytes in size. It is our exploded view of a machine suffering an explosion. It's quite interesting trying to work out what each of the bits are. Memory, voltage regulator units, CPUs actually here. Moving on. So here's our call to action. Not massive change from the previous machine, apart from the 4 shocks below. Lots more performance in here, lots more memory, and we now have these PCIe cassette access. I'd be careful when moving the PCI blind spot cassettes in and out, because it's the first generation of these sorts of things, and you just don't treat them harshly. Let's just leave it at that. So electricity, the different connectors, it's 5 inches longer, it's really heavy, and it's a bit noisy, so that's it. Here's the crew, me, Gareth, and Mike Pearson in the middle, in what was our secret rack full of the exciting kit. You can see in here is the actual machine with the 4 big fans in here. We haven't got a cover on ours because it was early ship. So as a reminder in here that the PDFs for today's slides and the replay will be available on the PowerVG website. They're actually stored on YouTube now, and we combine them with the AIX virtual user group that's now called the Power Systems virtual user group. They're all in one channel, so you can find those. And tomorrow's will be up there later that day as well. If you want the PowerPoint, and we've got lots of links, lots of things are appearing all of a sudden that nobody told any about. There's some nice 2-page summaries of the fact sheets and things like that coming out, and we'll give you links in there for the performance report and our comments on that as well. And that's it from me, JT. Do you want to grab back?
Hi, thanks, Nigel. That was amazing, and you probably need to rest your voice a little. So I will just remind people that we will be taking questions in a little while. Just a reminder that tomorrow's session will cover the E980, similar sort of detail, and we'll be kicking off at the same time as today. Another 90-minute session coming up. By then, hopefully, Nigel will have recovered. He's been working very hard getting all the material together. As you can appreciate, the announcement was only made yesterday, so there were lots of last-minute changes to be done. So thank you very much, Nigel, for covering everything that you did.
You're all welcome.
Brilliant. So I'm going to stop the recording there, and then we'll stay on to some questions.